video is brought to you by mywayteaching.com.
Next is enthalpy of solution. Enthalpy of solution. What is meant by enthalpy of solution? Do you have any idea about enthalpy of solution? So enthalpy of solution of a substance. See, enthalpy of a solution. Enthalpy of solution of a substance is the enthalpy change when 1 mole of it dissolves in a specified amount of solvent. One mole of it is dissolves in a specified amount of a solvent. So the enthalpy of solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interaction between the ions are negligible. See, the enthalpy of solution at infinite dilution, okay, is the enthalpy change observed. We can observe the enthalpy change on dissolving the substance in an infinite amount of solvent. Just consider this as a solvent, okay. So dissolving dilution in the enthalpy change, we can observe the change in enthalpy observed on dissolving the substance, okay, so in an infinite amount of solvent when the interaction between the ions are negligible. So the enthalpy of solution, the enthalpy of solution of ABs, how we can represent in this can be represented enthalpy of solution ABs, okay, that is delta solution AB A plus delta lattice delta, okay. So we can represent this one. So and then when an ionic compound dissolves in a solvent, okay, in a solvent the ions leave their order positions on the crystal lattice. See, in this only crystal lattice there are now more free solutions, but solvation of these ions also occur at the same time. This is shown in diagrammatically for an ionic compound A B. Water is therefore determined by the selective values of the lattice enthalpy. So enthalpy of hydration of ions, enthalpy of hydration of ions, this is called hydration of ions, okay. So as plus is equal, sorry, this one is equal to this is equal to delta lattice Okay, so this is for most of the ionic compounds is a positive, and the dissociation process is a endothermic reaction. Dissociation process. Endothermic reaction. Next, coming to the concept, lattice enthalpy. Okay, what do you mean by lattice enthalpy? The enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous state. So, for example, Na plus Cl minus. This gives Na plus Cl minus. So, that is delta lattice, which gives plus 788 kilojoule per mole. Okay, so it as according to this definition, just observe the lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound is dissociates into its gaseous ions in gaseous state. Okay, and since it is impossible to determine lattice enthalpies directly by experiment, we use an indirect method where we can construct an enthalpy diagram called Born-Haber cycle. So about Born-Haber cycle I will explain it later. Let us now calculate the lattice enthalpy of Na plus NaCl by following steps. So find lattice enthalpy. So lattice enthalpy, calculate lattice enthalpy of NaCl. Okay, so first step is Na, which is in solid state, that will be converted into gaseous state. Sublimation of sodium metal, so that is delta is equal to 108.4 kilojoule per mole. Okay, and the second one, Na, which is in gaseous state, is converted into Na plus gaseous plus E minus the ionization of sodium atoms, ionization enthalpy. So this is delta I is equal to 496 kilojoule per mole. Okay, third one, move into chlorine, which converted into gas. The dissociation of chlorine, the reaction enthalpy is half the bond dissociation enthalpy. So that is half the bond association enthalpy. That is 121 kilojoule per mole. Next is fourth step, which is gives okay electron gained by chlorine atoms, the electron gain enthalpy. So that is electron gain enthalpy is equal to minus 348.6 kilojoule per mole. So and next one is fifth step, Na plus, which is in gaseous, Cl minus in gaseous, which gives Na plus Cl minus, which is in solid. The sequence of steps I will shown in the figure. This is called Born-Haber cycle. What? Born-Haber. See, in this you can observe that is what just now what I have discussed with the steps up to 5, 3, 4, 5. Okay, So this is about the Born-Haber cycle. The sequence of steps what I have explained as is shown in the figure, that is Born-Haber cycle. The importance of the cycle is that the sum of the enthalpy changes round a cycle is 0. Okay, so this is the Born-Haber cycle. Next, spontaneity. What do you mean by spontaneity? It means spontaneity means having the potential to proceed without the assistance of external energy. Okay, having the potential to proceed without the assistance of external agency. A spontaneous process is an irreversible process and may only be reversed by some external agency. It requires some external agency. If you want to reverse it, may only be reversed by external agency. So this is called spontaneous process. And what do you mean by spontaneity? I will write you. Spontaneity means having the potential to proceed, potential potential to proceed without the assistance of external energy, without the assistance of external energy. Okay, so this is about the spontaneity.